Hello everyone, welcome to today's webinar on Elevate Your RRAM and MRAM design experience to the next level with eMemory. My name is Sean Wu and I'm your moderator today. Today I'm glad to have Joy Lee from eMemory to share with us some insight of these emerging non-volatile memory technologies. Hi Joy.
Hello Sean. Hello everyone. My name is Joy and I'm marketing manager of eMemory. And I'm glad to be here to share our perspective of emerging memories.
Thank you, Joy. So let's start from the very beginning. So RRAM and MRAM has been mentioned a lot recently, and my understanding is that the discussion are brought up because there are some issue for the existing technology when it's being scaled down. What's your view as eMemory specializes in non-volatile memory?
Okay, thank you for the question. We all know that when the technology process node goes below 28 nanometer, current existing memories have some challenges. The major problem is that floating gate memory no longer scales effectively. So we think MRAM and RRAM are obvious alternatives. So eMemory as a professional ENVM provider, we also think MRAM and RRAM are new opportunities to expand our product portfolios and help us to reach new market and new applications.
So Joy, thank you for the sharing on the scalability issue and how it could be solved with RRAM and MRAM. But on top of that, what are the other advantages RRAM and MRAM could bring to us?
Okay, in addition to the scalability problems, we also think that MRAM and RRAM can meet a variety of new design requirements. Like MRAM is non-volatile, and the cell size is smaller compared to traditional SRAM, and it is fast enough and with high endurance, so it can be used as cache memory. And for RRAM, we think except the advanced logic nodes, we think RRAM is suitable for specialty processes like high-V and BCD platforms because it requires less masks to be produced compared to traditional embedded flash. So it is also can be used as multi-level bit storage and which should be used for computing in memory and newer narrow design circuits. So we think MRAM and RRAM do have some potential to solve existing problems and can bring more values to us.
Thanks, Joy. So RRAM and MRAM seems to be quite beneficial in special process node and advanced process. So what kind of application would RRAM and MRAM be most suited for?
Okay, since the most important idea is to replace eFlash under 28 nanometer, so supposedly for all the advanced microcontroller or even microprocessor can be potential market for MRAM and RRAM. And like MRAM can be used for applications that needs instant on or prevent data loss, like SSD controller or FPGAs. And we also know that MRAM performs well under radiative environment. So we expect that MRAM may be needed in industrial or aerospace applications. As for RRAM, it provides an easier integrated solution to be embedded in many kinds of MCU or SoCs for IoT. And we also heard some discussions like using RRAM in a smart card or RFID or even display driver ICs. Yeah, so we think the most important thing is MRAM and RRAM do have some new features to help IC designers to realize new ideas. They break some limitations of legacy memory technologies.
So Joy, as you have discussed the advantages and potential applications for the RRAM and MRAM, I want to ask some further questions. Basically, in order to have this advantage and they target this specific application, I assume it must be related to their spec. So could you take us deeper and share some insight with us?
Okay, let's take a look into this page. This page shows our RRAM and MRAM reference specs. Our RRAM has been qualified on UNC 22 nanometer ULL platform with 16 megabits density. The design kit is ready for customers to use. Right now, we also receive many requests from customers for various RRAM specs. Our roadmap is as follows. First, we want to lower I/O voltages to 1.8 volt. This will help reduce the power consumption and be very beneficial for low power applications like advanced NCU. Another direction is to make the RRAM suitable for automotive applications with high temperature operation and retention. We are also planning to qualify higher endurance at 125 Celsius degree for more application scenarios. For MRAM, the right side shows our preliminary spec for a 22 nanometer platform. As you can see, we focused on its read, write, and wake-up speed due to fast operation consideration. The qualification of this MRAM project is undergoing. We expect that we will have more MRAM data in 2024.
So, Joey, we have so far talked about the technology and the applications. Then the next question I would like to ask is that, so what do we need to be aware of when taking RRAM and MRAM into our design?
Okay, RRAM and MRAM are very different from from existing floating gate memories. Right now we know many RRAM and MRAM players, they are focusing on the cell technologies, like the material layers or the stacking structures. And indeed, the cell technologies are the core of MRAM and RRAM, but if you want to embed these new devices to many kind of chips, it requires additional knowledges. Take RRAM as example. Most of the oxide-based RRAM requires a foaming process, and to make the filament into variable resistors. And sometimes it requires pre-cycling to stabilize the right window. And the analog signals like V reference, I reference, or clocks also needs to be trained for accurate control to enhance its reliability. And on the other hand, MRAM is sensitive to its rebias, and the sensing window is kind of narrow. And in many scenarios, people need to read MRAM in a very fast speed. So this makes the read circuit design even harder. So we may need some special design to the sensing amplifier, and analog signals like also needs to be trained for accuracy.
Thank you, Joey. So with this many different characteristics you just talk about, does that mean there are more verification that needs to be done as well?
Yes, indeed. Right now we know many RRAM and MRAM players have their own cell technologies. So some situations like if you want to make two different products into different foundries, the above mentioned parameters will be very different. So it will be very impractical to design these memory blocks by yourself. So professional design services can obviously reduce your design time and design cost. So this is why eMemory want to provide design services to help our customers to using these cutting-edge new technologies.
So eMemory has been known for its non-volatile memory business, whether that's floating gate or anti-fuse. It's OTP and NTP technologies. But people probably haven't heard much about the design service part, which you just mentioned. So could you elaborate more on how does this design service will make the implementation of RRAM and MRAM easier?
Okay, I think some other aspects that need worth to be mentioned is like we know that usually RRAM and MRAM requires ECC or and the repair functions, and to improve its yield. Therefore, some concerns appears immediately, like how many repair lines we need, and how many bits of ECC would be required. So these features helps to improve the yield very a lot, but it will inevitably have some size penalties. So to measure the trade-off between yields and size is important, and it requires comprehensive manufacturing knowledges. Furthermore, DFT-based and testing interface, these are also important aspects that will determine the testing time and the cost of RRAM and MRAM. So eMemory have dedicated design teams with experienced experts to deal with this digital peripheral design. So we can make sure our customers to have optimized PPA and testing costs.
So moving on, as you just have mentioned, the customer's requests are heading in various directions, whether it's for density, power, retention, or speed, right? And you also mentioned about the actual verification work required by these new technologies. So it seems like it will take quite some time to get this emerging memory to be designed in. And I think people must be wondering by now, like how long should people expect for an IP to be ready to be used?
Okay. Let's take RRAM for example. If our customers require RRAM on a new platform, the development timeline would be like the upper part of this slide. We will need roughly 13 to 70 weeks for IP design, and after test chip fabrication, another 13 to 17 weeks are required. And in the last phase, we will need 22 to 26 weeks to do qualification after received qualas. So generally speaking, if we assume fabrication time are like 15 weeks, the total RRAM development time for a new platform would be around 1.5 or 2 years. Depends on the fabrication schedule. And if you use our RRAM on a qualified platform with customized spec, the development time of RRAM IP is like the lower case. Basically, we only need design time and probably need test chip characterization to check the design works properly. Around 1 year or less, you will have your customized RRAM IP ready to be used.
So, Joy, thanks for the explanation on the design service part. Now, could you give us a summary of eMemory and eMemory's role in the wave of RRAM and MRAM?
Okay, we are the largest pure ENVM IP provider in the world, and we have been conducting ENVM business for over 23 years. We have 300 professionals, and roughly 17% of them are IP developers. And we work very closely with worldwide foundries, and sometimes we also work with FA and the packaging house. So we focus on reliable manufacturing to make sure our customer have verified and reusable and reliable ENVM solutions. And now we are expanding our product portfolios like MRAM and RRAM design services, and we can provide total solutions to our customers, like OTP for MRAM and RRAM repair or trimming. And since one of our targets is to replace eFlash, we think our security solutions from our subsidiary Puff Security could be very helpful, because we believe that MRAM and RRAM will soon have same requirements, that is to add some security features to protect our customers' data in the memory. So look around the IP companies in the world, you will find out that eMemory is the only company that is so focused on EMV and IP business. And we are thinking seriously about protecting our customers' important data in the memory. I think these are the unique values to our customers and partners.
Thank you, Joy. You have shared quite some interesting insight and very useful. So to the audience, our Q&A session remain open. If you have any question, please leave your question here. We are more than happy to take your question and get back to you. If we don't have time to get back to your question today, we'll make sure we get back to you after the event. Thanks again. Thank you, Joy.
Yes, thank you for watching this webinar, and I will be happy to answer the question you have.
The first question comes from the audience. It's about the availability, about our RRAM and MRAM IP availability. So which fab do we have this IP available?
Yes, okay. Currently, our RRAM has been mainly available on UNC 40 nanometer ULP and the 22 nanometer ULL platform. And both of them uses 2.5 volt I/O devices. And we are, as we mentioned in the webinar, we will provide different spec, like lower I/O voltages, and preparing to pass auto-grade RRAM IP. And for MRAM, we are discussing with major foundries to use MRAM cell from several US companies. The qualification is undergoing. So this is the roughly status of our RRAM and MRAM IP.
So, Joy, the next question will be, is the RRAM cell designed by eMemory?
So far for RRAM, we mainly use tantalum oxide RRAM, and the cell technology is licensed from Panasonic, who is a leading player of RRAM technology. And we think it's a well-verified technology, so it could be a reliable RRAM solution.
Here's the next question, Joy. For the secure application, like key storage, for example, which will be the preferred solution, MRAM or RRAM?
Okay, for security application, we think both MRAM and RRAM can be used to store the like ROM code or algorithm. But if you want to store the key, the security ID or something, we think probably OTP is a better choice, because OTP is more reliable and a verified solution and a well-known solutions. But we can probably we are still thinking we can combine OTP and MRAM and RRAM together. So this is also possible direction, and also our PUF solutions.
Joey, here's the next question. What are the density range for RRAM and MRAM, like eMemory could offer?
Okay, for density range, we mainly qualified RRAM up to 4 megabits in 14 nanometer and 16 megabits in 22 nanometer. And for MRAM, we target to provide MRAM in 32 megabits density.
So thanks, Joey, on the density part. So is the RRAM ready for production? That will be the next question from the audience.
Yes, our RRAM IP has been available on UNC 40 and 22 nanometer, And as we mentioned in the webinar, the design kit is ready to be used.
Thank you, Joy. So follow up with this question. So the next question would be the specialty platform that this solution, the emerging memory could be available, as you mentioned in the webinar. Right? So are the RRAM and MRAM available, or will they be available like in Hy-V or BCD platform? If so, when?
Okay, for Hy-V and the BCD platform, right now we do have some projects preparing RRAM on Hy-V platforms, but it's still on early stages. And if you want more details, please contact our sales directly for further information. And for BCD, due to the fact that most of the BCD platform is still above around 65 nanometer, so we will provide our NeoFlash flash technology in related platform. And we are also seeing if BCD technology will migrate to under 28 nanometer. If so, then we will probably porting RRAM or even MRAM onto related platforms.
Sure, I think in the Q&A session right now, there are a few questions all about the size of the IP. So why don't we combine these questions? Can you address the IP size questions all together and give the audience some insight from the perspective of the size? Thank you.
Okay, I think IP size will depend on the specification of RRAM IP. Exact density, the factor like endurance, speeds, etc. will affect the area of RRAM IP. So if you want more details, please contact us directly for further discussions. Thank you.
So, Joy, as you mentioned about automotive related part in the webinar. So there's a question from the audience asking if the RRAM can be used for automotive grade zero applications, for example, 150 degrees Celsius with 100 hours.
Okay, so far we do working on automotive grade applications, but it's still undergoing and under verification, qualification. So yes, so far we are working on 25 Celsius degrees and 150 Celsius degrees is one of our targets.
Sure, I also see another few questions regarding the cost, but from the other perspective. So how many extra masks would this emerging non-volatile memory need? Can you care to address?
Okay, both of MRAM and RRAM only needs 2 to 3 additional masks to manufacture.
So from the density perspective, so you just mentioned about the density that our IP are currently available, but what about the variation of the density? Are there other density also available?
Okay, in terms of density, as I just mentioned, that RRAM has been qualified in like 16 in 22 nanometer platform, and the density is up to 60 megabits. So supposedly under this, the 16 megabits density, it should be ready for our customers to use. And for MRAM is up to 32 megabits. So the density is smaller than this number is ready to be used.
Joey, I see a couple of questions asking about magnetic immunity of MRAM. So from your perspective, could you share some insight on this topic? Seems to be a big thing for MRAM.
Yes, we do think the magnetic immunity problem of MRAM is kind of the weakness of MRAM. So you may need additional design to cover this weakness. And if we will think that if you really have some concerns to use MRAM memory in magnetic environments, probably you can thinking about other solution like RRAM.
So to continue with the MRAM questions, there's a question asking about MRAM's availability at 40 nanometer ULP process. Is there any roadmap?
Okay, we think above 28 nanometer, MRAM is not necessarily better than existing solution like embedded flashes. So the roadmap of MRAM on 40 nanometer, we will see, we think currently we have RRAM solutions on 40 nanometer ULP platform. So probably we will see if there customer request of MRAM on 40 nanometer.
We have a question regarding the working mechanism of MRAM and RRAM. So Joey, is the erase mechanism in page or bit?
Okay, both MRAM and RRAM are direct write. So it's usually it's write in bytes.
So Joey, can MRAM be used for boot up? And how many write cycles does MRAM support?
Yes, we think it can be used for boot up. And for the write cycle, we are targeting around 10 to 6 cycle times, around 1 million cycles for MRAM. And if you need more higher endurance, we can discuss. So you can contact us for further information.
Okay, one question just came in that asking about the access time of this emerging technology. So Joey, the question is the access time in 20 to 30 nanoseconds or faster?
For the access time, take RRAM as example. RRAM is just roughly 20 to 30 nanoseconds. For RRAM is okay. And for MRAM, it can be maybe faster.
So for the very last question, is RRAM faster for the page write time compared to eFlash?
Okay, it depends. If you want to do direct write, I think RRAM will be faster, and but it also depends on the memory configuration. So in some condition, maybe eFlash will be faster.
Thank you, Joy, for your sharing today. And we also appreciate the audience participation and your questions. And thanks again for being here today. We look forward to seeing you next time.